Hello. A lot of people.
Ooh, hello. Welcome, Samuel.
So we are waiting.
No, it's not working yet.
We are still waiting for the technical part to be
Oh, come on, I thought we were clapping and it's already
to be in place.
No, we were clapping on the test.
So this talk will be about creation of a cryptocurrency. I'm not like a crypto guru or someone telling you what kind of investments you can do or how you can get a Lamborghini or whatever you want. We will totally not focus on the value, like the monetary value of a coin. We will focus on how it works and how you can create one. The idea is to remove this kind of mystery about token or I don't know, whatever, a Ripple or say Ethereum, Bitcoin, whatever project you can think about. In media, you see a lot of hype about all of this. But behind the kind of monetary value, there is other reason to create token. And what we want this evening is to learn together how it works. And it was also a way for me to kind of force me to experiment a bit with it. And also just because I don't have the habit to make talks, so sorry if I feel a bit stressed. It's my first real talk with a lot of people. So just tell me if I'm going too speed or too fast, and I will try to calm down a little bit. Yeah, it's working? Okay, cool. So, we have three parts. The first part will be about just getting some knowledge about blockchain and cryptocurrencies. That's what I call the crypto crash course. It shouldn't be too long, but it's very important to have some kind of overview of what is a blockchain and what is a cryptocurrency and why is it called cryptocurrency when you already have existing currencies. Then we will have a part where we will talk about the kind of theory behind the creation of cryptocurrency. And then we will see together how we can create the Optio coin. So it will be, we will try live to create a new currency.
Can we buy it?
Sorry, what?
Can we buy it today?
You want to play?
Buy it.
Ah, you want to buy it?
From Sam.
Yeah, I mean, you could, yes, in my private network, but yes. Okay, so let's start with just the kind of common definition that you can find. So a cryptocurrency is a digital currency. So it's something that only exists in a kind of virtual form in the network. It's not something that you can have physically. It's so a digital currency that uses a cryptography for just, in general, I will say security. It's not a very good way to explain it, but for now that will be enough. So because we are using cryptography and cryptographic methods, we get some features such as the difficulty to counterfeit the currency. So it's very difficult, and you have a lot of obstacles if you want to just create your fake Bitcoin that is considered valid by other people. it's not something that is issued by any central authority, or it could be, but in the general form it's not. It's totally decentralized, so it's not something that can be managed by just one authority or a group of people. It's something that exists and kind of live by itself. It's a kind of, it's a network that's manage itself by the different actors and the way they will interact together. So, and another feature in general, it's public. So you can, everybody can access everything, and everybody can become an actor and take part of this kind of network. So similar to the euro, a cryptocurrency is a general purpose token. It's something that you can trade for goods or for services. So you have every kind of market system that you can imagine with. And the cryptocurrency only exists in this kind of system, distributed system that we know as blockchain. Outside of this, the thing doesn't exist and doesn't have any value in itself. It's a bit different from some what we would call fiat currencies, so more like real currency that we have, say Euro, USD, or something else, where the thing is regulated by a central bank, for example, so they can decide to emit new euros. They can like decide to apply new regulation, or just to refuse. Some country can decide to refuse to recognize one currency or something like this. So geographically in the world, you can or cannot use some currencies. That's something that doesn't exist in cryptocurrencies, because the network doesn't care about borders. That's something that doesn't exist when you can just connect via internet. So that's just to give a kind of very high-level description of what is a cryptocurrency. Okay, now we will talk about the important part. It's the blockchain. That's the major thing that define or that differentiate cryptocurrencies from other currencies. It's because they are part of what we call a blockchain. So just to go to the basics, something I'm sure you are all very familiar with. How do a normal payment mechanism work? Say we have Mr. A and we have Miss B, and A want to pay to B. So in general, it will be very simple. The mechanism is we have two balances, and we will remove from A and add to B. So if you have your cash money, it's very easy. You have your wallet, you take your money, you give to the other person. If you don't have your wallet and you want to be able to just send money to someone else, in general, you will use PayPal or any kind of third party that you can imagine. It can be your bank, it can be anything, like any payment processing you can think about. And now you have the person A will ask the company to make the payment, and the company will remove from the balance A and add in the balance B. So now with a system like this, there is this core feature, like a core component. You need trust in between actors. You need the two A and B to trust the third-party company. The third-party company has to remove the money only once from A, write it only once in B balance, and the payment company shouldn't modify past history. When a transaction has been done, it has been done, and it shouldn't go back in time and decide, oh, now we will just change the history, and the accounts of two people are totally messed up. You have to trust, basically, the system to behave correctly. And that's exactly what blockchain is trying to fix. Blockchain has been designed to create an environment where you don't have to trust other actors, and you don't need third parties. You can do directly peer-to-peer transactions without any third party, and you only need to trust basically the mechanism by which the network in general will achieve a consensus. So, I can give you a kind of definition of a blockchain. I think it's kind of abstract. It's not always easy to visualize what it could be. So a blockchain can be defined in a lot of ways, but one way to think about it, it's a persistent, it's transparent, public, append-only ledger. So a ledger is, I didn't know what it was before, because English is not my native language. So a ledger is a kind of history of transactions. You see this in people doing booking, where you have all the transactions from one account to another. And that's what you use to know the balance that you have in one account, just if you don't know. And a blockchain can be think as a ledger, but where it will not be possible in practice to change the history. You can only create a new transaction, and one transaction, when it has been validated following a specific algorithm, when it has been validated by the different actors in the network, it will be considered the past, and that's considered the truth. It's not something that can be changed. It's a distributed network, so you can imagine a kind of graph where each node in your graph will be an actor, and they can communicate in between them, peer-to-peer. You have one algorithm that is used to reach a consensus in between the actors. What that means is you have one algorithm that will, from the different, each actor at one moment in time can have a different vision of the state of the ledger. And you have one algorithm to reach one consensus from all the different views of different actors. I will not go in the details of the algorithm because it's very technical and kind of complicated. And I don't think I have all the understanding of it. So, what you achieve with all of this is a design where you don't have to trust, the actors don't have to trust each other. You trust the mechanism, and that's it. And you can review the mechanism. You can review the algorithm to see if you think it's secure or not. All of this, in general, is open source, and you have documents to just explain the different parts. So you can review all of this and decide if you will trust it or not. It's similar to cryptography in other domains. For example, the kind of cryptography that we use when you have HTTPS for a website, where you have an exchange of certificate or something like this. It's also based on those kind of technique where you everybody knows about the mechanism. If you trust the mechanism, you don't have to have a trust in the different actors. So if you have questions, don't hesitate to stop.
Can you use blockchain for internal accounting as well? Is it something that people are doing?
For internal accounting?
Yeah, like we have finance department, for example, could they use blockchain for accounting?
It's similar, so it's configured like a blockchain. So if you have account movements, you can't manipulate all the account movements. You can just do the opposite way.
You said you can or cannot manipulate?
So you cannot manipulate it, but you can do a reverse movement, right? So you can transfer it in a different direction.
Yes,
So
correct.
It's like it's offsetting each other.
Correct, but I think for an internal system, the thing will not be distributed. You will not have like machine anywhere, everywhere in the world, in different countries, and where anybody can just join and participate in the system. So yeah, you could do it for internal. It seems to be overkill, but maybe you could do it, for example, if you have multiple companies and they want to share one maybe history of transactions. Say, I don't know, for some reason you have, let's say, Microsoft and Apple and Facebook, so they are everywhere in the world with office everywhere in the world, and they want to collaborate for some reason, and they want to share one kind of past of like one history of transaction, but they don't want to trust each other because they are competitors. It's just something I have in mind. In this case, maybe that could make sense.
Sounds like the answer for peace.
For?
For peace.
World
World
peace.
peace, yeah.
Ah, oh, okay, that's interesting.
498.
So we could create OptioPays. Just an idea. Okay, so I have this. That's a kind of overview of the system. So no, I don't think I will go in this. You have that's basically the network, the different nodes. You can a node is just any machine. It could be your fridge maybe, or anything that can connect to internet and can yes, get any access to internet and communicate with other machine as part of the network. You have basically you will create one transaction, and you will have some actors in the network who will do some validation. Different blockchain use different way to incentivize people to do validation. If I think about Bitcoin, in Bitcoin you have the mining mechanism. So you have some machine in the network. They will face a kind of challenge where they have to guess a number. So they have to do a lot of math, basically, very fast. And if they guess the correct number, they will get a reward. That's how new Bitcoin are generated. So it's a way to create an incentive for people to be part of the network. That way the network itself just will grow over time. And at the same time you have a kind of market that is created for this, and it's a way to create Bitcoin to control kind of the creation of new Bitcoin over time. So you don't have a giant pool of Bitcoin that one person own from the beginning. It's over time that you have new Bitcoin, and they are distributed kind of democratically. In other blockchain, if you think about Ripple or XRP, they don't have those kind of things. From the beginning, you have all the coin that exist. So you have different way to create different incentives depending on your goal. For Ethereum, they have a different system, totally different system, where you have a kind of mining mechanism and a reward for people who run some kind of programming language. Basically, you write an application for the Ethereum network, and people will be rewarded if they execute some part of the application. So it can be very complex. At the same time, the possibilities are just very interesting. But yeah, in general, you have the network, you create some transactions, the transaction will arrive, will be communicated from one node to the other nodes using a peer-to-peer system. You have the different node will validate using cryptography. They will validate the transaction. They will emit that the transaction is validated and communicate to the other node. When it reaches enough validation, the network will consider, oh, that's a transaction. I will add it to the history and create a new block. That's why it's called a blockchain, because you create a new block, it's part of history, and you will connect the block together. And in general, each block has a reference to the previous block. So you can verify very quickly if one block is correct, exists or not. You can validate it very, very quickly. And depending on the type of blockchain, that can take a lot of time or be very fast, or you have a lot of different parameters. So just to, I don't know how you are familiar with currencies, cryptocurrencies, but you have just two big names, Bitcoin, Ethereum, so Ether is the name of the currency. Two different implementation of blockchain. The first one, Bitcoin, is a kind of payment processing implemented on top of a blockchain, so you can send payment to other people, and you have this kind of mining system to generate new coin. Ethereum is more like a distributed virtual machine in a way. It's like one giant computer that exists. It's Skynet basically.
Ah, nice.
It's like one computer distributed anywhere in the world. Anybody that has a node running, being part, that has a node that is part of the Ethereum network, is a little part of the virtual machine of Ethereum. And the goal of this is basically to create a kind of more generic blockchain, such as other people can create new application, new maybe token on top of this one. It's a way to abstract the blockchain for other people who want to create new projects. So same kind of concept, but totally different implementation. And yeah, in general, you have the market cap because people give some value to Ether or Bitcoin. It's not really rational the way that works, but it seems to be something important. That's not really true anymore. You have different. You can have a kind of challenge that is being used to create some kind of incentive. For the two, you have the same, something called proof of work. You have other kind of challenges that can exist. For the two blockchain, it's being used to mine or generate new coins. And okay, the rest is not very important. It's just some names, if you want. It's It's the computing power that exists at the moment to try to win the challenge. You have basically the miners, what they have to do is kind of guess a hash. So they have to calculate hash, a lot of them. And the hash rate, it's the number of hash, I think, per second maybe, that the network can calculate. So all the machine together, how much calculation they are doing. And by doing the calculation, at the same time they do the kind of validation processing. So the more you have, the more the highest the hash rate will be. In theory, the highest the transaction rate you can have. So you can have way more transaction per second if you have a lot of hash rate.
So you mean to solve the entire blockchain or to get one?
To find the next block. You have a challenge to find the next block. And when they find the next block, if you want, you have the different nodes, and they will try all of them to dig. The kind of mining metaphor works pretty well, I think. They will try to dig to find the new, like ore, I think it's called, or RE. So the new metal or whatever, the new ether. And the one that find the thing will say to the others, I found it. The other will verify, and if it's true, this person can create the block and add it to the blockchain.
So 3 terahash is like an order of magnitude less than 2 orders of magnitude less than 1.8
Yes, you have way, or I'm not sure, those data, I'm not sure where when they were measured. But yeah, you have way more people interested in Bitcoin than Ethereum. Bitcoin, basically, currently it's like the king of cryptocurrencies. Yeah, I'm not sure how much.
So, like, as I remember, actually, it's 10 and the power of 18. It's about 6 level 1 meter per hash rate.
But it's not up-to-date values.
It's changing every day.
Yeah, that's correct. And it's very easy for miners to move from one blockchain to another. So if they see one coin is more valuable just right now, they will just switch.
But you need GPU versus ASIC, right? So the calculations are different.
Yes, that's correct. They have totally different hardware to do the calculation, yes. But as I said, it's not up to date. I'm not sure if you can do ASIC now for Ethereum, but I would guess after 2 years. I'm not sure about this. But yeah. Okay, so that was a lot of information. As a reward, you have just some cats for
Someone is away.
and more cats because of rewards. Okay. So,
It's the best time around.
do you have other questions? Because we will start to talk about more like the creation of currencies. No? Okay. So, let's first just talk about white papers. It's in general what you can use to evaluate different blockchains technologies, or if you want to read more about some specific currencies. You have totally different type of white papers. You have the Bitcoin white paper is kind of the most well-known. It's an overview of what is Bitcoin, and it reads more like an academic paper maybe. But then you have, for example, the Ripple solution guide. It's also considered a white paper, and it reads more as a marketing, maybe kind of flyers or something like this with nice pictures. So you have totally different kind of things, because sometimes people just create a white paper for ICO, so you need something nice to attract people, and sometimes it's more to do some technical research. In Ethereum, it's a wiki in GitHub, so different projects, totally different way to approach the thing. But in general, it's a good way to get correct information about blockchain and cryptocurrencies. Okay, now if we want to create a coin, we need a blockchain. That's the basics. You have three ways. Yeah, you have basically three ways to create to get a blockchain. So you can get, say, the Bitcoin project. You can fork the source, so create just a new version of the source and modify it as you want. And now you have your own Bitcoin that you can call Bitcoin, maybe Bitcoin Cat or whatever you want. And you can play with the different parameters and try to hack the code to do something different. That's not always a good idea. As you can think, you have a lot of code to read. You have to go deep in the technical of Bitcoin. Something else that you can do is use a system such as Ethereum, where you can create already on top of Ethereum, you can create a new coin or a new project or something else. It's done using something called smart contracts. Basically, you will use a programming language, write your contract. We will see together how it works. And you have already tools to interact with the blockchain, and you don't have to care about a lot of things. So in general, people are using more smart contracts. And when you have a company with a new idea of a new kind of blockchain, they will do the crazy thing to start from scratch and just try to do something different with different incentives, different kind of challenges, different way to connect nodes together, something totally different. But for us, we want to learn, we want something with documentation, we want something where we can experiment, so we want smart contracts. It's a very good way to just start. You already have the blockchain, you have documentation about the programming language that you can use, you find examples. So if you want to experiment with this, smart contract is the way to go. So, what is a smart contract? A smart contract, it's basically a program, an application that will define some rules, the rules of the contract, and that will exist in the blockchain. It's kind of abstract, but as a way you can think about, for example, if you want to do a bet, you want to do, I want to do a bet with Andrew. I bet that tomorrow will be a sunny day. We have basically three different ways to handle the situation tomorrow. We check the weather. We have to decide how we check the weather, so we have to agree on this. Maybe we will write a contract because we don't really trust each other, and we want to use laws to enforce something. So we will maybe write a contract, say we will check at this time in the day, using this tool, if it's sunny or not. If it's not sunny, I owe you some money. Otherwise, you owe me some money. But then you have to deal with the law, you have to do all of this. And if now you want to handle other people, you have to redo the same thing every time. And then we have to basically handle the contract as we do it in real life. The other situation is just basically we do nothing, and maybe you will give me the money or not, we don't really know. Or we will try to find another weird way to enforce the thing. So with the concept of blockchain, basically you can write something that will look a bit like this. It's just an example of code. That's for a token, but you could imagine that you have rules that will say, okay, every day at, say, 12 in this location, so using one specific tool, we will check what's the temperatures. I will go back because you look all at the screen, and that's not what is important. So you could write a program that will basically check for you the date, how we check the temperature, and if it's true or not, if it's sunny or not, the money will be sent, and it's automatic. You write this, and it will be done. It's not something where you can then try to find a way around. It's something that will happen. That's a smart contract, or a way to think about a smart contract. It's a way to enforce rules by encoding them in a blockchain. You write them using a programming language. In general, in Ethereum, you use Solidity. It's a kind of object-oriented programming language. It's kind of okay. I don't have a lot of experience with it, but until now it's okay. Something that you have to know when you write a program, it's not always easy to delete it or modify it. So if, for example, I write, say, a bot that will just do something simple, and at one point I realize, oh, my bot is doing something that I don't like, it's not always easy to just say, I will delete it or modify it, because it exists now in the blockchain. So you have from the beginning to think about how I will destroy my bot, yes.
So don't we have a sort of emulator or debugger to test it before publishing?
Yes, we will see together after. It just, in general, it's a totally different way to think about how you develop your application, because the context will be different. But then you have something running in the blockchain that can interact with the blockchain. And because of this, you can do very interesting things. For example, you could create an application that will handle, say, insurance contracts or something like this. Okay. Some cats. We arrive at the end of the part. A reward. More cats. That's for you. And more cats. Okay, and now we arrive at the difficult part of the talk. So we will do the live demonstration. But first, why would we want to create a new coin? So that's kind of the normal thing, I guess. You could all imagine, because of the hype, you have someone who arrive and say, hey, we need a coin because we need a coin. And now you can see you have Kodak creating a new token, you have Telegram creating a new token, you have any kind, we will have Apple at one point. So for us, the reason we know why we want to create a new coin, it's to learn. So we will stay very, very, very simple. We will not try to do crazy things for now. We want to have basic informations. We want to have name, the symbol of the coin, say you have the little euro thing or something like this. We want to have balances, and we want to be able to transfer the money from one address to another. So very simple. But it's good to learn. Okay, let's try. Da-da-da. Okay, so I have a private Ethereum network running on my machine. To do this, you have to generate something called a genesis block. It's like the first block, and from this, you can kind of bootstrap the blockchain. So you will add the block to a database, and you have all the blockchain that can be bootstrapped on top of this. It looks maybe a bit complicated. It's not. You have the connection to the network. It's like one node running here, and I have a little console where I can interact with the Ethereum virtual machine. So we can, for example, say, send a transaction, or you have a little interface and you can do some operations that send some money from one address to another. And then we have this. Maybe you know, I don't know if you have experience with this. If I can make it a bit smaller. So it's called just Ethereum wallet. It's a client, what they call a wallet. You can create an account and have a wallet. Basically, you have one address and you can get some money. It's like your balance. You can think about it. It's a bit similar to your bank account. So you can have money and you can see the transactions. In the world of blockchain, people can create as many wallets as they want. It's very cheap. Like, it doesn't cost anything. It's very cheap from a storage point of view. So that can be very interesting. You have people trying to create more kind of pseudonymous or anonymous, but not always, system using those kind of things. And something different. If you think about a bank, each account is a real person. It's not the case with blockchain in general. You have accounts, and one account can be just, for example, a bot using the account or something like this. You don't have like one person behind an account. Not always. Okay, so that's just a graphic client for Ethereum. You can see here, it's a bit small, but it's written 23, and you have 2 minutes since last block. So as I said before, we need a kind of a mining system. We need people doing those kind of challenges and validating transactions for the system to work. So we have this in this environment. Every time we do a transaction, we have something that will automatically validate it. That way we can experiment. It's way easier. So you have a kind of miner running in the background. So just for us to have something simple, we will do a set interval. It's a JavaScript console here, so it's kind of cool for people who know JavaScript. And okay, so now we have every 2 seconds we create a transaction and generate some validation. And so if I go back,
There are some errors on the console there, right?
it's normal.
Jasper.
It's a feature.
So now every 2 seconds you can see it's increasing. So we send money from my account has every Ether possible, so I'm very rich in this world. It's not the case in real life, but
Maybe it's time to buy things.
and you can see every time you have like new block received, and that will allows us to validate the creation of the smart contract. For example, it's a transaction. We send some data saying that's one smart contract with some information, the sources of the contract, for example. So you need the validation to work. Okay, and now from this interface, you have this kind of little editor where you can write directly Solidity, so the programming language. You can write the code directly here. And then you will see we will have parameters. You can specify them. And you can directly from this interface deploy to the network. So you can do exactly the same for the real network Ethereum. You can use this interface, go in contract, write your little program, and deploy. But you will have to pay a little fee to reward the people doing the validation. Okay, that's just to see a bit the tools that we have. I need my Emacs. It's somewhere. It's here, okay. Okay, so let's start like this. It's a bit, okay. Is it visible enough? Because it's like white and, okay, let's do it differently. How is it called? Atom? Yeah. Do you know how to change the theme or to make something less black? All my theme and everything are black, so.
Could you look at the room?
I never use Atom. Maybe we have someone who do.
Can you try to open in console?
On the right hand side you have blocks and there's choose a theme.
Ah, okay. Okay, perfect. And we want something light. Let's light syntax maybe, light UI. How does it work?
You see things on the left? Can you click? Yeah. It's so close.
Where do you see
You
this?
see, yeah. Okay. The cursor a bit top.
Theme,
Yes,
this?
theme. Try it one more time. And before to rush into this.
I want this, no? No?
Okay.
Maybe it's already installed.
It is
Okay.
installed.
Selection, packages, theme, window, I don't know.
You can go to help and actually search for things. The last
It's not
That's
very.
the theme,
Probably preferences.
Yeah, okay, I will use Emacs.
even though we're not agree.
And I guess I can do.
Okay.
I
I'm
okay.
sorry to match, it's okay.
Okay, okay. So we will create a new contract. We will call it. Let's call it Optio. Oh, I think I already have one new Optio coin.
Can you call it hobby coin?
Holy coin?
Oyster coin.
Yeah, we can do this. Okay. This one is not okay.
Have you asked Oli Oster what color he wants his object coin to be?
So we can do this, like add a field to have a color or something like this.
We
Okay.
all agree on the logo, right?
So Holy coin.
No, Oyster coin.
How did you write this?
OSTE.
OSTER
R coin.
coin. Okay. Where is my? Okay, I have it. No. So the first thing we need to specify. What the fuck?
What?
Okay.
No, that was Oster.
Is it big enough?
Oh.
Thanks for that.
Is it big enough? So, very good joke today. The first.
It's not a joke.
the first thing we have to do, we have to create a new contract. So it will be called OptioCoin.
Right, same thing.
Same thing, it's not correct?
No, OptioCon.
Well, it can be OptioCon, no? That's a good way to describe it, maybe. Okay, and then we need to create something to have a balance. So it's not very important, but basically that's a way to create a mapping in between addresses and an amount. Then we will need a name. Book. So we do kind of everything global for now. That's totally okay. We need decimals. We said that we want a color. So let's say a string. And we want a color. And we will want a symbol. Okay. So with this, we need a constructor. So OptioCoin. With this, we have the basics of a smart contract. We can already deploy this, but it does nothing. It doesn't interact. Basically, you have a useless program that cannot be used for anything. So we want to be able to transfer OptioCoin from one address to another. So we will create a transfer function method. It's public because it will be public. It will be accessible from by anybody using the Ethereum network. And a transfer is described by an address to, and we give an amount, like value. So it will be something like this. We have the balance. Message is a special name here. Oh, it's blue. It's not very easy to read, but it's message sender. A message is the message sender is the person, or like the account that is running or executing, calling the function. So for us, it will be the person who wants to transfer the money. Okay, so we remove the value. That's what we've seen before. We remove from A and we write to B. So 2 and we write a value. So if we have this, that will work. But it's very simple. We don't do any check, so people can have just empty balances, and that will work. And that's not necessarily what we want. So we will just add some check, very simple check. We have require balance off. Messenger, I will just copy because it's not very important to see me typing. Okay, so we do some sanity check. We check if it's not, if the value is higher or equal to the money that the person has. And we check if the person who
is positive.
Sorry?
And the second one is the value is positive, right?
Yeah. You have the correct. Okay, so just some sanity checks, and then we need just something a bit special. It's called an event. It's a way to notify different. Basically, you can listen to a function and react when someone calls a function. And an event is a way to signal to people that something happened. So for example, you can imagine that you have a bot listening to the method transfer from one contract. So you have a company creating a contract, and you want to know every time the method transfer is called and maybe react to this in a way. So you can subscribe to this, and then every time you have an event, it will be triggered like this. Say transfer, that's the event, and you will be able to react. That's how you do very interactive client. If you have experience with wallets, you know how the interface is very reactive. Every time you see a new transaction coming and everything is up to date, it's because of those kind of things. And we need to, we have the event, we need to declare it before. Okay.
Simon, why did you put the right side of the and on the first line of transfer?
This?
Is it necessary? Because 2 is always, the value is a positive number.
We don't know if it's positive.
It's
It's-
unsigned integer. No big deal. I just wanted to make sure that it's necessary.
So maybe not. Maybe not, yeah. So for now, I will just keep it, but we can check later. Yeah.
Sure.
Okay, so that's the basics. With this, we should be able to have our coin. So before, because it's we know that when we create a smart contract, it will live for a very long time. It's not always easy to destroy it. For example, we have nothing to destroy it. If we want to be able to destroy it, we should create, say, a kill method or something like this. So define how the smart contract will be destroyed. We don't have this for now. That's okay. We just have our private network. But we want to be sure that what we have is correct. So we will compile it. I use a tool called Truffle. It's a little framework. You have a lot of features with it. Perfect. It's checking. We have a warning. So it's not a big deal. It's not even in the one we are dealing with. Okay, nothing important. I will just fix it. So we do the check. Everything should be correct. Perfect. Okay, and now we want to import the contract in the blockchain. So the way it works, you have to, you need the sources. So we will go back. I will do it on my side. Author coin. I copy paste. We go back to this. We will copy paste this. You can automate it. I copy paste because you can see it's more interactive. Now you can select the contract, and you will see the different parameters. I forget to do this. In the constructor, we should specify our parameters. So oyster. Every time I think about oyster or coin, well, never mind. That's not what I want. And it's oyster coin. Okay, so very simple. We have parameters. We assign everything, and we need something for the color. color equal say token color, and we will add a string called token color. Okay, we copy this, we go back to this, and we paste, and we see that we have an issue because I haven't copied the correct thing. So I go back here, our store coin. I copy, it's because of my Emacs. Okay. We pick the contract, and we see now parameters. So let's say the initial supply that we have maybe, let's say, a lot of them. We decide for a name, so oyster coin. And we want a symbol. What kind of symbol can we have?
Oyster emoji.
What?
The Ollie emoji.
You want an emoji?
The heart. No,
So, okay, let's try. I don't know if a string can be an emoji, but
We can try.
what do you want?
I don't think they
Yeah, but you have them in Slack, you know?
Yeah.
Okay, so we will not have it here. But we can have oyster.
Yeah, when you talk to Apple, they should
Oh,
add all the oyster to everybody, right?
Ah, no, you don't.
I agree.
So let's take, for example,
Facebook.
let's not take an emoji because I'm pretty, I'm pretty sure that will not work. Something?
Letter A.
You're the art director or no? Director. But, okay. That's the symbol of our coin. And we need a color.
Pink.
Mauve?
But
No, pink.
Mauve, not pink, okay. And the decimal unit is for some clients. Okay. So that should work.
Decimal units is a precision?
Sorry, what?
Decimal units 2 is a precision 2, or what the word?
The decimals?
Then yeah, you put 2.
Yes. So basically, the way I understand it, I'm not exactly sure about this, but for example, if you think about Ethereum, or if you think about Bitcoin, you have like the Satoshis. It's the smallest unit you can have. But one Bitcoin is something like, I don't remember how many Satoshis you have, but it's like 10 power, maybe something like 12 or something like this Satoshis.
Okay.
So yeah, it's the number of decimals that you have in one unit.
It's the smallest denomination currency.
Yeah, I think so, but I'm not sure exactly. But I've seen that it wasn't working correctly in the interface without this, and it's coming from the documentation. We are doing a hello world currently, so it's not high level.
Question about the contract. Is there a interface for a contract? So if you want to deploy the contract on the network, does it need to comply to some functions? I think that you have the send balance, right? Or
You need, so you have the events. If you want people to react in a specific way, for example, the transfer event is important if you want, for example, graphical client to listen to your contract. So that's a kind of interface. Then you need just a constructor. It's very free, like you can do whatever you want, but in practice you have some kind of how to say standards that people do. So you will find, for example, like buy, sell. If you have something that interacts with other currencies, you will have a transfer. It's very basic. You will have maybe, if you have owners, you will have the possibility to freeze an account. So you will people will expect something, but you don't have to follow. It's not enforced. Okay, so we send the contract. We create a transaction for this. we will wait for the transaction to be validated. And then it can take a few minutes if you do it in the real network. For us, it's very fast. And then we can see the author coin exists. You have the address of the contract, and you can see the parameters. So the information about, the public information about the contract. You have the name, you have the decimals, you have the symbol, and the color.
Can somebody send him a WhatsApp? Oliver Oster.
To send him a WhatsApp?
Yeah, show him that.
Oh yeah, okay. But first we can create basically a wallet. We will create a new wallet. We can call it, say, Oliver. Is it correct? Oliver Oster? Okay. So we just create a new wallet, and then we will see that we can send author coin book. So now if we send from one wallet to another, I should have my list of wallets, and this one, we can see Ether. I have a lot of them, and I have 1,000 bots. And now I can decide. So if I go back to Oliver Oster, I get the address. Okay, copy anyway. I take my wallet with the bots, and I send to the address, and we will send, say, 1 bot. So what we did is very cool if you think about it. We have a new currency. We have full control on it, and we can decide who we want to send the currency to. And if we do this on the main Ethereum network, we could send the currency, the token, to anybody that has an Ethereum wallet. So it's the basics to create a new token, a new coin, are very, very simple. It's something you can do in a talk in less than 1 hour. So, okay, you missed everything. But we created an account with some bots, and we transferred 1 bot to Oliver Oster. So if we check Oliver Oster, we should see 1 bot. Okay. So that's it for this kind of demonstration.
I have a question related to that. So basically, like one Ethereum, like you said that you have 2 wallets, Ethereum and Oster coin. So
yes.
Basically, this is like sort of the same thing. Like main Ethereum have just like simple contract, and that is actually 1 Ethereum, and all other things are just using the same network sort of.
Yes.
So basically, when somebody buying Ethereum, they actually buying one of these bots, for example, but just like a general one.
No, they don't. They buy. It's separated.
But the same level entities, like 1 bot and 1 Ethereum in your network, it's pretty much 2 different contracts, right?
Yeah, but they exist totally separately.
Yeah, but using the same network for transfer.
Yes, correct.
Okay.
If, say, Ethereum doesn't exist anymore, our coin is dead.
The network would work still or not?
Sorry, what?
So, for example, if Ethereum doesn't exist in the network, if you only have bot in your network, basically.
Yeah, that will work.
Okay, but when you pay the transaction fee, you pay it in bot or in Ethereum?
Ah, okay, you will pay them in Ether.
Okay, because you basically, like miners, what they do is they actually validate your contract, and
yes.
you pay them in Ethereum.
Correct, yes. For everything related to the network, you will use Ether. Okay. And now you have this little bot that you can transfer from people to people.
Like Ether is the same thing as a bot, it's just a contract basically. One of them just was pre-existent, like.
Yeah, you can think about it like this, but it's a kind of, it's the only one you can use to reward the people who maintain the network, if you want.
Okay.
But then you could, for example, create another concept of miners on top of this, where people mine bots, if you want.
People who
Can
mine
we
bots need to
please
pay
do
ether.
that?
So basically, when they mine bots, then we need to pay ether for transaction fee.
Yeah, I guess.
So it's like
It's something I'm not sure, but that's what I would think. But
last question is
yeah.
how you control emission. Is that when you said 1,000? That's basically now the whole your coin have only 1,000.
yes.
Okay.
But
So
we could create a new method. Yeah, I can show you how you can interact with an existing contract. Because you could create a new method that is like increase supply or something like this, where you can specify how much you want.
So you basically can emit money like how you want.
If that's what you want to do, yes. You could have this. And you could, for example, restrict to one address. So only you can generate more money. So basically, when you have the contract, okay, that's Oliver. If I go in my, yes, we can do it like this. If you see the transactions, you have Oster coin, and it's written admin page. So you can see the parameters, but you can also see the functions. So you can call transfer, and we could define another function that could be, say, increase supply, and you specify how much you want.
And only you can do it.
Yes.
Okay.
You could do something. I had in mind to do this for the talk, but it takes a bit more time. I had in mind, for example, like every time someone say but let's say this on Slack, you generate a new coin. It's a way to mine coin.
If you want to be rich.
So you increase the supply every time you see an event like this, and then you can maybe send coin to other coworker to reward them or something like this. You are not fixed in this.
When you create a coin on the Ethereum network, do you bind it somehow to Ethereum? So like to Ether? So there's like some kind of exchange? Like let's say 5 parts into Ether or something like that? Or
When you do what?
when you create a coin
Ah.
on the Ethereum network, to use the Ethereum network.
You have to pay some fees that will cost some ether.
But can you do the exchange from the coin you create and Ethereum?
You could do this, yes. I mean, you could have, in your new contract, you could define a way to buy and sell some ether for your token. So that's the end of the talk. But if you're interested by those kind of topics, and maybe you want to experiment with a bit more with it, I have in mind to have a kind of workshop where we can we define some kind of tutorials or some kind of goals of things we want to create. And one idea I had in mind was to be able to interact with other currencies. So if you're interested by this, just tell me, and we can see how to create something a bit more interactive, where you can all try to create program for the Ethereum network. It's very interesting if you think about it as a contract, because at least for me, I think about it as application, so I stay in my kind of domain, say software development. But if you think about it as a contract, it can be a contract in between people, and it can become more social, or it can just leave the world of software development and become more something that you see in any case, like anywhere in the world, like in your life. For example, say I said before, insurance contracts. You could have. You could imagine, for example, a way where people are rewarded if every year, maybe if they are still alive or something like this. In a way to check if they are alive. I don't know how you do this, but you have some money that is allocated, and you maybe say a pension coin that is created or something like this. And when they stop working, they can use the pension coin to get their pension. So maybe you have a way to simplify some bureaucratic work that exists or things like this. It can go outside of the domain of just software development. So yeah, just something I have in mind. And sorry, it was a bit too long. I had in mind 1 hour, but yeah.
Thank you.
Thank you.
Thank you.
Cheers, man.
Now you can
Thank
just
you.
say butts.
Yes.